Alright class, here we go. Section 9.3. We're going to deal with circles today. We're going to find equations of circles. And so let's get some notes. This should be a fairly easy section. So first thing, you all know that this is the center of the circle. And in most cases this will be 0, 0 for you. You know this red line right here will be your radius. Okay, and this whole circle right here, all these points, there's an infinite amount of points on this circle. All these points on this circle can be represented by the equation x squared plus y squared equals r squared. X is the x coordinate, y is the y coordinate, so each one of these coordinates, x, y, will be equal to, if you square them, equal to r, which is your radius squared. Okay, so r is your radius. So question number 1. It says graph an equation of a circle. Alright, identify the radius. Well, very first thing here, the equation isn't the way it's supposed to be written. It's supposed to be x squared plus y squared equals r squared. And right now it is not. So let's make it that way. So all we have to do is take this and put it over here, so we have to add x squared on both sides. Now it becomes x squared plus y squared equals 36. But now if I asked you what is the radius here, a lot of people say 36, but really this 36 is representing r squared. So what we have to do off to the side is say, okay, r squared is equal to 36, which makes, if you square root that, r equal to 6. Now technically plus or minus 6, but we're talking about a radius. A radius cannot be negative, so that's why we just take the positive root. So we have the radius is 6 of this circle, and the center of the circle is 0, 0. That's the way it's going to be in this section. So, and you could tell, actually this is the real equation, x minus h squared plus y minus k squared equals r squared. And that's technically the real equation. And as you notice, we just say x squared plus y squared because h and k are 0 and 0. That's where our center 0, 0 comes from. So we're just dealing with the normal equation right here. So let's go graph this. So if we had to graph this, one, we have to know our center, and our center is 0, 0. And two, we have to know our radius is 6. So here's the easy way to graph. So we go to our grid here, and let me just get a blank one. So just draw it quick. Alright, our center is 0, 0. Now if you wanted to graph a circle, all you have to do is this. Here's the easy way. Since our radius equals 6, what you have to do is this. Go from your center and go 1, 2, 3, 4, 5, 6 this way. Go 6 this way. Go 6 up. And go 6 down. And then draw a circle best you can. I'm actually going to use one of these and draw one. There we go. Okay, so that's how you find out what your radius is. You just solve for r, and you plot r up, down, left, and right. Okay, find your center 0, 0. Alright, pretty easy. Example number 2. Alright, so what they do is they tell us a point that lies on the circle, whose center is the origin. So what they want is, what is the standard form of the equation? So they want the equation. So you should be thinking x squared plus y squared, because the center is 0, 0, equals r squared. So basically all you have to do is find out the radius. That's all. So, and that all comes from this. So I drew a picture of this. So let's try to find this. So here's 2, -5 on the circle. We want to find the equation of the circle. So really we just have to find the radius. Well, if we know 2, 5 is on the circle, let's just draw a radius quick. Since the center is 0, 0, if we just kind of make a dotted line to here, we can figure out how long this is. So all we really have to do is do this. We could use the distance formula, right? We could say, okay, the distance from 0, 0 to here, so distance is equal to square root, this is what you learned in section 1, is take the x's, so subtract the x's, we can say 2 minus, this is 0, 0, there's 2 minus 0 squared, plus subtract the y's, -5 minus 0 squared. So we get the distance is equal to square root of, this is 2 squared, which is 4, plus -5 squared, which is 25. Distance is equal to square root of 29. So there you go. That's one way to find out what the radius is. So this length is square root of 29 units long. Here's actually another way. Just use the formula x squared plus y squared equals r squared. X means the x coordinate. The x coordinate in this case is 2. So we go 2 squared plus y, which is -5 squared, should equal your radius squared. So 2 squared is 4 plus 25 equals r squared. So this is 29 equals r squared. And we got just r, d is the same as r, in this case, is 20 square root of 29. So when you come out to your equation, x squared plus y squared equals r, which is square root of 29 squared. But really that's not a good answer. I mean, square root of 29 squared is just 29. X squared plus y squared equals 29. That's your best equation right there. So that's how you find the equation of a circle, just given a point on that circle. Basically just put that point into really the equation up here, and you'll find your r, or your r squared, and you can put it back in the formula. So this is what they wanted. They said find an equation of the line, or I'm sorry, of the circle. There it is. Alright, the next type of example is trying to find an equation again of a line tangent to the circle. So you have to understand what a tangent line is. A tangent line goes through one point of the circle. Every point on this circle has a different tangent line. Okay, and that tangent line is perpendicular to the radius at that point. So this point here has a radius, and this tangent line is perpendicular to that. So every point has actually a different tangent line. So perpendicular is key because you have to find the slope of this so that you can find the slope of the tangent line. So let's do that. So what is the equation of the line tangent to, so x squared plus y squared equals 13, and this point. So let's do that. Alright, so I'm gonna draw a quick tangent line. So what I drew here was, I drew 3, 2, and then I drew the radius. So I know my tangent line has to be perpendicular to this. So I'm just gonna draw a line and see how close I get here. Okay, probably not, that's not perfect, but you understand the process here. So the first thing we should do, let's find the slope of this segment right here. Okay, so that's actually pretty easy. If you think of a triangle, right triangle here, from this point to this point we go down 2 and right 3. So rise over run. we rise down 2, so -2, we ran +3. So our slope of the tangent, or I'm sorry, the slope of the segment is -2/3, which tells us, or should tell us, the slope of this line right here. And you know that it should be perpendicular. So therefore, you guys should know, you did this last section, if it's perpendicular, then the slope now has to be the opposite reciprocal. So this is negative, so our new one will be positive. This is 2/3, so therefore 3/2. Okay? Now think about what we're trying to actually find. We're trying to find the equation of this line right here. So since it's a line, I'm thinking y equals mx plus b. There's our equation. We have to find the slope of this line and the y-intercept of this line. So since we found the slope of the red, we can find the slope of this line. So the slope of the row is -2/3, which means the real slope of this line has to be 3/2. So I'm going to put that in, 3/2. Now, we don't know b. We can't guess it from up here. We don't know it. But we do know a y and an x, a coordinate, right? Well, the only coordinate that you know that is on this line is this one right here, -3, 2. So all we have to do is put that coordinate into y equals mx plus b. So let's do that. The y value is 2 equals m is 3/2, and the x value is -3. The b we don't know, so plus b. So let's solve. 3 equals, what is that, -9/2 plus b. Add 9/2 to both sides. So b is equal to 2 plus 9/2. So 2 is 4/2 plus 9/2 is 13/2. So there's my b, and we had our m up here. Put these two things together inside of y equals mx plus b. So y equals m, which is 3/2, x plus b, which is 13/2. Final answer. This is the tangent line. Alright, let's talk about circles a little bit more. We said that this, let me get this pen. If we talk about this circle right here, all the coordinates on this circle is x squared plus y squared equals r squared. What about all the coordinates inside of this circle? If I had to shade this area right here, all the coordinates on the inside is actually, so let me draw something here, x squared plus y squared is less than r squared. Okay, that's everything on the inside. And now, if we shaded the outside of the circle, you can probably guess how I can represent that right there. So, if everything on the outside of the circle will be x squared plus y squared is greater than r squared. That would be the outside of the circle. So understand this concept, which will lead us into the next example here. Alright, example number 4, cell phones. So a cell tower services a 10-mile radius. You get a flat tower 4 miles east, 9 miles north of the tower. Are you in the tower's range? So let's set the tower at 0, 0. Okay, and it says you get a flat tower 4 miles east, 9 miles north. So let's go back to my picture here. Let's see, this one right here. So this 0, 0 is our tower. Our tower has a 10-mile radius. We're going by 2's. 10-mile radius. So if we start here, they say we go 4 miles east and 9 miles, what was it, north. So let's start driving. Here we go. 4 miles east. There we go. There's 4, and then 9 miles north, 2, 4, 6, 8, somewhere right around in here. I don't know if it's inside, outside, who really knows. Okay, so it's saying, are we inside or outside? Are we in the tower's range? That's what it's saying. So are we in the range? Well, based on the picture, you don't actually know. We could be a little bit on the inside of it. We could be a little bit on the outside of it. We could be right on it. Who knows? So how are we going to figure this out algebraically? Well, it says, are we in the tower's range? Which means, are we on the inside, it's saying. Let's go back to the question just so you see it again. Are you in the tower's range? If I said, are you outside of the tower's range, we'd be looking on the outside of the circle. But it says, are we in the tower's range? So it's basically asking you, are we on the inside of the circle or not? Well, you just set up an equation. That's all you do. Well, if we're asking, are we on the inside, we'd say, okay, x squared plus y squared is less than r squared. So what do you know? Well, you know this right here, that dot, wherever you are, 4 miles east, 9 miles north, so 4, 9, is that on the inside of the circle, within, or outside, or on? Who knows? Let's check it. 4 is your x, 9 is your y. Put them in. So we got 4 squared plus y, which is 9 squared. Is that less than your radius? Okay. And our radius is how much? Well, we said 10 miles. So here's our tower. This tower has a 10-mile radius. So are we within a 10-mile radius? So 10 squared. That's where I get my r from. Okay. So all we have to do is check if this is true or not. That's it. So 4 squared 16 plus 9 squared 81. Is that less than 100? And what do we got? 97 is less than 100. That is true. So therefore, this point right here is on the inside of the circle. So therefore, it says, are you in the tower's range? You would say, yes, we are in the tower's range. Now if we picked a point out here, then obviously this wouldn't work. This would be false. Okay? So this is how we find if we're in a tower's range or not, or if by using inequalities with circles. So if I asked you, hey, are we on the outside of the tower? Are we in the tower's range, or are we outside of the tower's range? You would say, you would just change this to greater than if I said outside of the tower's range. Okay, something like that. All right, last question here, example 5. A little bit tricky, but let's just follow the slides here. In example 4, suppose you fix your tire, then drive south. So we're looking at the last example we just did. Okay, how many more miles will you be in range of the tower? Well, let's look at the picture. Okay, let's go back to this. So we are up here right now at 4.9. We're on the inside of the thing here, and it says we drive south until it says how many more miles will you be in range of the tower. So well, just think about it. You keep driving south, how many miles we got so far until we come to right here, right? So from here to here is how far we will be. All we have to do is figure out the distance from here to here. We know this point is 4.9. What do you know about this point? Well, we drove straight south. Well, I know one thing about this point, the x value. This was 4.9. Well, this is 4, comma something, right? And we'll just call it y. So you need to figure out where this is right here. Okay? So what we'd have to do is we'd have to use our, since this is right on the curve, we're going to use x squared plus y squared equals r squared. You're just going to put in 4 and you're going to solve for r. Okay? We're going to find out what this coordinate actually is. And once we do that, we can just find the distance from here to here. But the key part to this question is, what is that y value and how do you find it? Okay, so let's go back to the slide. How do you find that y value? All right, so solution. When you leave the tower's range, we'll just look at this right here. You're here at 4, 9. When you leave it, you'll be at the point on the circle x squared plus y squared equals 10 squared, whose coordinate is 4, and whose y coordinate is negative. You know you're below the x-axis, so you know you're going to have a negative number right here. So all we have to do is find this point right here, 4 comma y. How do you find it? Okay, on this circle, x squared plus y squared equals 10 squared. All you have to do, what do we know about this coordinate? We know the x value, right? So what we're going to do is we're going to put our x value in here, and we're going to solve for y. Okay. I might have made a mistake on the last thing I was talking about on the last picture I was looking at, but this is what we're talking about. We know this. We know this circle, this edge of this circle is x squared plus y squared equals 10 squared. We know the x value because we drove straight south, but we don't know the y value of this right here. Okay, so let's go find it. Okay, how do you do that? Well, let's plug it in, substitute. So there's our 4 for x, there's our x value. We don't know our y value, but we do know the radius is 10 of our circle. Okay, now solve for y. So minus 16 on this side, minus 16 on this side, right? Well, before we do that, well, I guess they went straight to the answer. Let's do this. This is really 16 plus y squared equals 100. Minus 16, we get y squared is equal to minus 16, what is that, 84. So we take the square root, y is equal to plus or minus square root of 84. Now that probably breaks down, but we don't need to actually do that in this case. But if 84 was just a decimal, it would be y equals plus or minus about 9.2. Now, we got plus or minus technically, right? But what is the real answer? Well, we went below the x-axis, if you remember, right? Our coordinate down here is y. It is up here. If you think about this point on the line is 4 comma 9.2. This one down here is 4 comma negative 9.2. So that's actually 4 comma negative 9.2. That's how we're going to find our answer. Now look at this. We have a coordinate here, 4, 9 to 4 negative 9.2. All you have to do is find the distance here. So from here to here is 9. From here to here is 9.2. So if you add those two distances up, you get 18.2. So that's the distance. If we go back to our question, let's go back and kind of look at the slides. Okay. All right, they don't explain too much, but let's go back to the picture, right? Okay, this is 4, 9. This is 4, negative 9.2. Find the distance between here to here. And it's the absolute value of the one, y value 9, minus the other one, negative 9.2. And if you do that, 9 plus 9.2 is equal to 18.2 units. Or actually, we're talking about miles. So 18.2 miles. So how many more miles will you be in range of the tower from here to here? 18.2 miles. There you go, guys. All right, so section 3 is done. Guys, get out your homework. I'm going to put up the worksheets on the website and do that. Just make it a good day, and I'll see you next time. See you guys on Tuesday. Make sure you know what's going on, and you have a quiz on Tuesday on section 9.1 through 9.4. So if that changes, I'll let you know, but that's the plan. So plan on it. All right, guys, have a good day without me. Take care. I'll be sunning in Thailand. Have a good one. Bye-bye.